Hi there and welcome to our latest edition of our Flip Learning classroom. Now today we're going to be looking at Group 7 and the halogens, so I will get on and let you know what the objectives are. Enjoy! Okay, so let's have a look at our objectives then for Group 7, the halogens. So by the end of this video you should understand these two objectives to be able to describe the properties of the halogens and to describe the reactions of the halogens. Okay, so we're going to look at the halogens today. Now the halogens are in group 7 of the periodic table, so it's this group here. So let's take a closer look at these. So we've got the group 7 here, which consists of fluorine, chlorine, bromine, iodine and astatine. Now as you go down the group, the size of the atoms gets a lot bigger. So if we start with fluorine, we've got fluorine, which is relatively small, and then we go all the way down to astatine, which is a lot bigger. Now the similarity that they have is because they're in group 7, they have, you guessed it, 7 electrons in that outer shell. Now we'll talk more about how they actually react later on in this video, but what we are going to just have a quick look at now is the reactions, the appearance of the halogens. Now we'll start with fluorine. Now fluorine is a very, very pale yellowy green gas, so you can see it just about within here. It is very pale and it is very volatile as well, so it is a gas. Now as we move down the group, we'll do chlorine next. Now chlorine is a very, very pale green gas. Now you can see it is slightly darker in colour than the fluorine, but it is a gas as well. Next on the list is bromine. Now bromine is a gas, but you often get this formed as bromine water, so that gas can actually dissolve into water, but again you need to keep it very sealed because the gas can often escape from the water. Now as we get even further down, we've got iodine. Now iodine is a black, purpley, very, very dark coloured substance. It's normally found as a solid, and the last one we've got is astatine. Now astatine is very unusual because it's very, very rare. There are only ever several hundred to several thousand atoms at any one time. It's very radioactive, so all we can do is estimate the reactions of it and the appearance of it. We think it's obviously going to be a bit darker, and it's also going to be a solid. So let's just have a quick review of what we have done. We have looked at the halogens, we've looked at their appearance. Now as you go down the group, they become more dense, so they become more solidified. So we've got a gas, liquid, solid. Now we can look at the formula for each of these. Now we'll just take a quick model of one of the group 7. So if we quickly draw this one here, now we can see here that we've got 7 electrons. Okay, now if we let's just move this nucleus into the middle. So 7 electrons, and then if we get the second one, we can put the 7 electrons on the outer shell on this one as well, which shows we have a covalently bonded molecule. So whenever we get these the halogens together, we find that they are always diatomic, so it's F2, or it's Cl2, or it's Br2. So all of them are diatomic, so they always have that little 2, so that we can show our full shell of outer electrons. Okay, so we're going to have a look at the properties of the halogens. Now we're going to have a look at the table. Now this is in your revision guide, so you can refer to this whenever you like. Now we've already talked about the appearance of all of these, but we can see that the melting point increases as you go up. So we've got the boiling point also going up as well, so you can see that at minus 188 that fluorine will be a gas, at minus 34 chlorine will be a gas, and then we can see that at room temperature bromine is going to be a liquid because it won't turn into a gas until 59 degrees, and then iodine is a solid, and then we're estimating these for astatine, and that's based on the pattern that we can see here. As we have already said, that astatine is relatively or very unstable, so we have to estimate this. Now again, we've also talked about the density, and you can see here that as you go down the group, the density increases. So we've got a very, very low density for the two gases. They're less dense than water, as you'd expect for a gas, and then the bromine and iodine, and again the astatine, all above 1 in terms of their density. Okay, now we're going to look at the reactivity of the halogens. Now we'll actually state what the reactivity pattern is. That as we go up the group, we get more reactive. So fluorine is the most reactive, then chlorine, bromine, iodine, and then astatine we estimate to be the least reactive. Now the reason why they're the least reactive is to do with their electron shells, or their outer shell of electrons. Now fluorine, or a smaller one that we can see here, is going to be more reactive than the bigger one that we can see here, and that is because the space in that outer shell for an electron is closer to the nucleus than it is here. So if we had a spare electron, or 2, okay, the smaller halogen would attract that electron to its outer shell a lot more than this one, and it's purely because of that attraction between the positive nucleus and the negative electron here. So there's less attraction here than there is here. So what this actually does, the same as the group 1 metals, we make an ion. So we put this in square brackets, and that becomes a minus ion, and this one does too. And that is because we've got this extra electron here compared to the charge within the nucleus. Now, as we've already stated, the group 7 metals are all diatomic. So let's call this top one fluorine. We're going to have F2. Now because we've got two of them, we're going to need two electrons, so we add two electrons, and that will make 2F minus. Now what I'd like you to have a go at is draw the reactions like this for the other four halogens. Now, in terms of oxidation and reduction, what we've done is the fluorine here has gained electrons. Now, if we follow the oil rig, oxidation is loss, reduction is gain. The electrons have been gained, so this, the fluorine, is reduced. Now the reactions with group 1 metals and the halogens are relatively simple. Okay. Now if we take this group 1 element, we've got one electron in its outer shell, and then this group 7 element has 7 electrons in its outer shell. So what we want to do is we will move this one electron to fill that outer shell. So let's say this is sodium. So we have sodium plus we have let's say chlorine, and what that will do is that will make NaCl. Now we need to balance that, so we put a 2 there and a 2 there. Okay, and it really is just that simple. So the one electron moves from the alkali metal to fill that outer shell on the halogen. Okay, so we're going to look at the reactions with of halogens with metal halides. Now a halide is an ion of one of the halogens. So it could be a chloride, fluoride, iodide, all of those. Now if we look at some results of some reactions where we've taken a halogen and reacted it with a metal halide, we've got chlorine will react with potassium bromide to make potassium chloride, and it reacts with potassium iodide to make potassium chloride, and you can see that the other halogen is formed as well. Now because chlorine is more reactive than bromine, the bromine will not displace the chloride in potassium chloride, and iodine is the least reactive, so it won't displace the chloride in potassium chloride or the bromide in potassium bromide. So let's have a look at the reactions. Okay, so let's look at the first reaction from that table then. That was potassium bromide, which would be 2 kBr plus Cl2. Now that will displace the bromine to form 2 KCl plus Br2. Now in your notes what I'd like you to do is have a go at doing another displacement reaction from one of the reactions that we've seen on here. Okay, so pick one and do the reaction pick two and do the reactions for them. Okay, so if we review what we have done there, we have looked at the structure of the halogens and the bonding that they have with each other. We've looked at the properties of the halogens, and we've looked at the oxidation reduction reactions in which they are able to gain electrons. We've also looked at the reactions where they react with alkali metals in group 1, and also how they can displace each other depending on their reactivity. Anyway, I hope you've enjoyed it, and I will see you again next time. Bye for now.